Part 7. Bases and pH. So as previously stated, in order to find out how basic a solution is, we typically need to know its pH. The higher the pH, the more basic the solution is. And as you can see, if it's above 7, between 7 and 14, it's basic. Well, 14 is also basic. And if it's below 7, then the solution is acidic. And at 7, it's neutral. So we need to find the pH. And for basic solution it would be above 7. However, how do we actually find the pH calculation wise? We know that the pH formula is negative log of the concentration of hydronium ion H3O+, which equals the pH. But in this equation, in this reaction for the base, we only have these OH- ions that were produced. So how do we exactly get the pH if we only have OH- ion concentrations and not the concentrations of H3O+? Well, here's a simple rule that you can memorize to know how to convert between the OH- concentration and the H3O+ concentration. At room temperature, the product of the concentration of H3O+ and the OH- concentration is always equal to 1 times 10 to the negative 14th in water. And this 1 times 10 to the negative 14th does not change at that certain temperature. And essentially, unless indicated, always assume that the product of the concentration of OH- and H3O+ is going to be 1 times 10 to the negative 14. It's just a rule that you have to memorize. And these concentrations, however, the OH- and the H3O+, can change, but this 1 times 10 to the negative 14 never changes. So if the H3O+ rises, then the OH- has to go down. Or if the H3O+ gets lower, then the OH- has to go up, because this product right here, the 1 times 10 to the negative 14, never changes. And from this rule, we can obtain the concentration of H3O+, knowing the concentration of OH- from the base, so that we could figure out the pH. So we would take 1 times 10 to the negative 14 here, divided it by the OH- here, divided by OH- to find the concentration of H3O+, this concentration. So if we divide this by that, we find the H3O+ concentration. And once we get this H3O+ concentration, well, then we can easily find the pH by plugging it into our negative log H3O+ formula, and we'll have the pH, knowing only the concentration of OH- produced by our base. However, if you do not want to convert the concentration of OH- to the concentration of H3O+ to determine the pH, because that can be a bit time consuming, then you can take a shortcut, and I'll show you how. Some people prefer this method, some people don't. Personally, I prefer this method, but it's ultimately your choice. So there's a formula that says pOH plus pH equals 14. Now we know that the P here stands for negative log of whatever's here. So essentially this formula is saying that the negative log of this OH- pOH plus the negative log of this H, but in water it's H3O+, equals 14. So we can see that from this formula we can find this pH, but we have to calculate the pOH. And that's very simple, because you know that the pOH is just the negative log of this OH- concentration. And then all you have to do is subtract that from 14 to get this pH. So 14 minus the pOH equals the pH. 14 minus this negative log of OH- will get you the negative log of H3O+, and that's the pH. So it's simple. Basically, as soon as you get this OH- concentration, all you have to do is get the negative log of it and just subtract it from 14 to get the pH. So this formula is a pretty fast shortcut that you can take to find the pH from the concentration of OH-. Pretty direct.